Hi, welcome to an audio test session with APx. These videos provide worthwhile information for APx users and demonstrations on a range of audio measurement applications. In this session, Dan demonstrates measuring MEMS microphones using the multi-input feature in APx500 software.
Hello, and welcome to this audio test session with APx. In this test session, we'll be looking at testing a pair of MEMS microphones, but we'll be taking advantage of a new feature in APx500 version 6.0, multi-input, or the ability to have two different inputs, in this case an analog input and a digital input, active simultaneously. To get started, what I have for a physical configuration is an APx525 analyzer with a PDM option, and I'm also using our APx1701 transducer test interface, which we'll be using to drive a source speaker as well as to provide power for our analog measurement microphone. So in my output configuration, I'm going to select transducer interface. I only have one channel active, and I'm going to turn on the power amplifier for that channel. On the input side, I'm also going to select transducer interface. I have only one channel active. I'm going to use it in acoustic mode since we're going to make some acoustic measurements. And I need to provide power for that measurement microphone, which is CCP style, or constant current power. Now I happen to be using a TEDS microphone, or a microphone with a transducer electronic data sheet, and so I can actually read the calibration information directly from the microphone using the Calibrate from TEDS button. I'll select Read TEDS Data, and then I'll select Set Sensitivity. And quite conveniently, my microphone sensitivity is now set. The next thing I'm going to do on the input side is I'm just going to crank down the bandwidth to 48 kilohertz sample rate, or roughly 20 kilohertz bandwidth. In this case, I'm making all my measurements within the range of human hearing, so I don't need to collect data above 20 kilohertz. Now, the last thing I'm going to do in configuring the analog input side is I'm just going to verify my connection. So I'm going to turn on the signal generator and see that I am indeed getting signal back from the speaker inside my test chamber. You can see that in the lower left-hand corner in the FFT monitor, and I can also see the level that I'm generating. Now, since I'm measuring a microphone, what I want to do is calibrate my output. So now I'll go back to the output side, and I'll go ahead and select acoustic output. And I'm going to select this acoustic output level button, which will bring me to our set acoustic output level dialog. And I'll say I want to set a target of 94 dBSPL. And I'll put in a healthy stop value. And now the system is going to automatically vary the level of the analog generator until it finds the output that gives me 94 dBSPL, or just about 1 pascal of sound pressure. So now I have the analog side of my measurements all set up. So now I'm going to go to input 2. This is the new feature in APx500 version 6. And here I'm going to select PDM. And as soon as I select PDM, you'll notice in the lower left-hand corner, I now have signal monitors for both my analog input on the transducer interface and now on my PDM. And I'll just go ahead and turn on the receiver outputs and the VDD so I can see a signal coming back from the PDM microphones I'm actually testing. Now what I'll do is I want to see some actual results from that, so I'll go to Add, Primary Result, and I'll say I want to look at the RMS level result coming back from the PDM input. Now right off the bat I have a useful result here, since I've gone ahead and set the output to generate 1 Pascal or 94 dBSPL by reference to a measurement microphone, and I'm getting minus 26 dBFS from each of the MEMS microphones, or minus 26 on one and almost minus 27 on the other. I am immediately getting the sensitivity. So these microphones, their specified sensitivity is minus 26 dBFS per Pascal, plus minus 3 dB, and I'm getting that result immediately. Now what I next want to show you is probably the most valuable feature of multi-input, which is now what I'm going to do is select Add Derived Result from my analog reference microphone, and I'm going to add a sensitivity result. The comparison data is going to be the PDM input, and I'll add 2 bars. And bar 2 will refer channel 2 of the PDM input to channel 1 of my transducer input. And just for ease, I'll select a unit of dBFS per Pascal. Now, right now you notice that this is exactly the same result as just the discrete RMS level result I got, but that's because I've driven the generator to 1 Pascal. If I go ahead and change the generator to, say, 80 dBSPL, you'll notice that the RMS level result has dropped by 14 dB, but the sensitivity result has stayed very roughly the same. And that's because what the sensitivity result is comparing is the ratio between 2 simultaneous input levels. And this is a very useful feature because very often when we're measuring a microphone, the best and easiest way to measure it is by reference to a measurement microphone. In general, it's much easier to have a measurement microphone than a measurement speaker. In fact, there is no such thing as a measurement speaker. What we can do is we can take a speaker and essentially calibrate it by reference to a measurement microphone. But in the technique that I'm showing right now, what we're doing is we're actually measuring the microphone under test directly by reference to a measurement microphone, essentially dividing the source speaker out of the equation entirely. This is just a single point result. Let's go make some actual measurements. Thank you very much.